Hello humans, I'm Mr. Khing. Alright, okay, so now let's go into this 2021 paper, October-November paper 43, past year paper. So let's get started. Q1, so which one is an element? So first, what is element again? Element basically means substance that cannot be broken up anymore or substance that contains only one type of atoms. So therefore answer is oxygen. Okay, next one. And out of aluminium, okay, aluminium oxide is also called bauxite. Gas that causes acid rain, it is sulfur dioxide, because you see sulfur dioxide is also an example of non-metal oxide, and non-metal oxide they are acidic oxide. Okay, then used as a fuel, it is ethanol. Ionic compound, remember you see ionic compound, it is made from metals and non-metals, so it is sodium chloride. Okay, then produced in Haber process. Haber process is used to produce ammonia. A product of respiration, okay, pretty easy. Carbon dioxide and H2O is produced during respiration. Toxic compounds of incomplete combustion. Here, let me see. Incomplete combustion will always produce carbon monoxide. And a gas produced in the test for nitrate ions. Let me see. Nitrate ions will always, the test for nitrate ions will always form ammonia gas. Okay, pretty easy for this Q1. Okay, next one, see Q2 we have about electrolysis. So first, what is electrolyte? Remember, okay, all electrolyte they are ionic compound. Okay, and ionic compound that can conduct electricity in molten or aqueous state. So when we say keywords isn't a key mentioned, okay, ionic compound that can conduct electricity. So you see in what state? Because we know that ionic compound cannot conduct electricity in all states. Okay, but it can only conduct electricity in liquid form, like example molten and aqueous. So this is the reason why, okay, there are two types of electrolyte, molten and aqueous electrolyte. Okay, then followed by electrolysis, okay, with the observation and also the names of the products at both anode and cathode. So you see, when it comes into electrolysis, isn't it? Okay, the very first thing to do is always list out the ions present in the electrolyte. Like example given here, aqueous copper 2 sulfate. So what are the ions present? See, aqueous what? So they are CO2 plus sulfate, hydrogen and hydroxide. Okay, aqueous solution. So anode will always attract negative ions and cathode attract positive ions. So which one will get selected to be discharged at anode? So you may see, always pick the one that is lower in the reactivity series. So therefore we know that hydroxide is lower, hydroxide gets selected. How about a cathode? Copper is lower, so copper get selected. So you see, when hydroxide gets selected, you see observation colorless gas bubbles form. Okay, and this substance that produces bubbles is oxygen gas. Okay, and then observation, you see, we know that copper 2 will get selected, so it produces solid. So therefore, solid is deposited, and the names of products is copper solid. Okay, next one, concentrated aqueous sodium bromide. So sodium bromide, hydrogen hydroxide. So same thing, negative ions to anode, positive ions to cathode. So which one will get selected? See, may see, anode, see, this is concentrated, is it? May see, if it is concentrated, halide ions will always get selected. See, at anode, is there any halide? Yes, there is. So therefore, bromide gets selected. And then it cannot, it has to be hydrogen. Remember again, those that located from aluminum and onwards. Again, basically those metals that are more reactive than carbon, they can only get selected to be discharged in molten state. So in this case, sodium, it cannot be, it cannot get selected in concentrated. It has to be in molten. So this is the reason why sodium ions will not get selected. Okay, and hydrogen will get selected instead. So observation at the anode, bromide gets selected. So observation, brown gas is produced, okay, due to the presence of bromine gas. And then cathode, colorless gas bubbles is hydrogen gas selected. Okay, then write the ionic half equation for the formations of hydrogen. See, hydrogen ions against electrons to form hydrogen gas. Balance the equation, 2, 2. And then what are the two reasons why graphite is suitable to be used as an electrode? Okay, let me see. Graphite is an example of inert electrodes. And all electrodes, okay, they are good conductors of electricity. Okay, let me see. The main functions of electrodes is to conduct electricity. It is to ensure that it is a complete circuit. Okay. And then, what is the particles that are responsible for the conduction of electricity in the metal wires? See, it has to be electrons. Okay, electrons that flow through the wire and ions can flow within the electrolyte. Okay, then next one, okay, Mohs calculation. Okay, so you see, you are asked to look for the relative formula mass of this ionic compound, lead-2-carbonate. Okay, so you see, based on periodic table, the atomic mass of Pb is 207 and 1 carbon 12, 1 oxygen 16, and there are 3 oxygen. So eventually you get 267. Okay, then what is the percentage of lead by mass in PbS? So you see, given here, the MR of PbS is 239. Okay, so what is the percentage of lead by mass? You see, percentage by mass. Okay, so PbS what? So what is the total mass for PbS given here? 239. Okay, lead by mass. So what is the mass of lead? You see, there's only one lead inside, and the mass of lead is 207. Then multiply with 100%. So eventually you get 86.6%. Okay, always remember to include the unit. Okay, very important. So next given here, you see percentage of lead by mass in PbCO3 is 77.5%. So use this information and your answer in B's. Okay, suggest whether it would be better to extract lead from PbCO3 or PbS. So you compare. So which one has a greater percentage of lead? Okay, pretty obvious, it is PbS. Okay, why? Okay, because the percentage of lead is greater in PbS compared to PbCO3. Okay, it is 86.6% compared with 77.5%. Okay, next one. Chemical equation for the thermal decomposition of lead-2-carbonate. See, products are given to you over here. Here, pretty easy. Just convert everything into chemical equation. So PbCO3 to form PbO and CO2. That's it. A balanced chemical equation. Okay, the next one. Okay, chemical equation for the reactions of lead-2-carbonate with nitric acid. So metal carbonate will always react with acid to form salt. So PbNO3 plus water and carbon dioxide gas. So you see, why is it Pb bracket NO3 again? Remember the charge of Pb2 plus NO3 negative 1. So cross metal, eventually you get Pb bracket NO3. Okay, balance equation is the right hand side. There are 2 hydrogen and 2 NO3. So this is how it looks like. Alright. Okay, then next one. Okay, how I say drawings of covalent bond. dot and cross diagrams. So we know that O26 carbon 24. Always remember this. The numbers of electrons needed to become stable equals the numbers of electrons for sharing. See, 26, it needs 2 more. So therefore, oxygen can only share 2 electrons. See, carbon from 4 to 8, it needs 4 more. So carbon, it needs to share 4. So you see, oxygen share 2, 6 valence, you share 2, 4 more outside. Okay, oxygen share 2, 4 more outside. Carbon share total for 1, 2, 3, 4. Ta-ta, eventually this is how it looks like. Always remember this, you see, this is what we call dot and cross diagram. So which means you have to change the symbol alternately to one another. Okay, the next one. Okay, given with this. So your answer should refer to the types of particles involved and the relative strengths of the forces of attraction between the particles. So why lead-2 oxide has a much higher melting point? So you see, by comparison, we know that lead-2 oxide is an example of ionic compound, and carbon dioxide is covalent compound. So first, you have to mention lead-2 oxide is an ionic compound. So therefore, it has strong. Remember, ionic bond it is also called electrostatic forces of attraction. Okay, and what are the particles present in ionic compound again? Okay, they are oppositely charged ions. That's it. Easy 3 marks. Always remember this in the exam whenever you see the word between the particles. So which means you have to mention, okay, what are the particles present in the compound? Okay, ionic compound, ions of different charge. Covalent compound, it is molecule. Alright, okay, please take notes about this. Okay, next one. Okay, I see. Given with this parts of reactivity series. Okay, you see, experiment 1, magnesium is added to aqueous lead-2 nitrate. Experiment 2, copper is added to lead-2 nitrate. So, okay, right, whether is there any reaction or not? You see, you can easily get the answer from the table itself. See, magnesium is more reactive than lead, so therefore magnesium can displace the lead. So therefore, there would be reaction. And you are asked to write the ionic equation. You see, what is ionic equation again? In ionic equation, we remove all the spectator ions. Okay, so to make it easier, isn't it? Okay, in ionic equation, we only include substance, okay, or ions or particles, okay, that undergoes physical changes during the chemical reaction. Again, so in this case, you see, metals undergo displacement reaction. So we include metal, okay, because in this case, you see, metals are those that undergo changes of physical state. Okay, you see, magnesium solid to form magnesium nitrate solution. Lead solution form lead solid. So Mg reacts with Pb2 plus to form Mg2 plus MPb. Again, the spectator ions, which is the nitrate ions, is removed. Okay, you see, nitrate, okay, remain the same before and after in terms of the state symbol. Okay, it is still aqueous before and after the reaction. Okay, experiment 2, is there any reaction? See, copper cannot displace lead, so therefore no reaction. Okay, next one, how to test for the presence of oxygen again? We can test with glowing wooden splinter. Okay, result, it will relight the splinter. Okay, and name the other gaseous products produced. So you see, when lead-2 nitrate undergoes thermal decomposition. Again, so you see, when metal nitrate undergoes thermal decomposition, they form metal oxide oxygen and nitrogen dioxide. So another gas produced is nitrogen dioxide. Alright, and then given with this element symbol. Right, okay, see, given here, let me see the top number, it is always the sum of proton and neutron, so-called the mass number. Okay, number at the bottom left hand corner, it is just the proton itself. So what is the numbers of proton in one atom? 6. In numbers of electrons, since there's no charge, isn't it? So same proton, electron, neutron, 12 minus 6, you get 6. Okay, proton 6, electron, same numbers of proton, electron, neutron 13 minus 6, you get 7. Okay, and then name 2 forms of elements carbon which have giant covalent structures. So what are the what are the giant covalent compound again that contains carbon? They are diamond and graphite. Okay, then next one, I see given here. Avogadro constant is the numbers of particles in 1 mole. Okay, which means whenever the numbers of mole equals to 1, this is the numbers of particles. Okay, so calculate the numbers of molecules in 22 grams of carbon dioxide. So first, we need to look for the numbers of moles in 22 grams of carbon dioxide. So you see, you are given with 22 grams in terms of grams. So therefore, the formula to be used to look for the moles of carbon dioxide, it is the mass formula. Okay, N equals to M over Mr. So M 22, and what's the Mr of carbon dioxide? So 12 plus 16 plus 16 eventually get 44. So 22 divided by 44, you get 0.5 mole. So 0.5 mole multiply 6.02 times 10 to the power of 23. So eventually the numbers of molecule equals 3.01 multiply 10 to the power of 23. That's it. Yeah, same thing you see, you're asked to look for the numbers of molecules in 6 dm³ of carbon dioxide gas. So first, what is the numbers of moles of carbon dioxide gas produced? Okay, you see given here are 6 dm³. Okay, volume. Okay, in terms of volume formula, numbers of mole equals V divided by 24 dm³. So volume given to you 6. So eventually you get 0.25 mole. Okay, so 0.25 mole multiply 6.02. So eventually you get 1.505 times 10 to the power of 23. That's it. So this is how look for the answer. Okay, then next one, titration. Okay, so you see titration between the reactions of sulfuric acid and sodium hydroxide. So why universal indicator is not suitable for this reaction? Why? Because universal indicator there is more than one color change. Okay, like example, you see when it's neutral, it can be dark green in color, medium green, light green in color. You see more than one color changes. So it is very hard for us to determine the endpoint. Okay, so what is the examples of indicator that can be used in titration? Okay, like example, you can use phenolphthalein, okay, or methyl orange, okay, any of these. Okay, and make sure you know how to spell the word phenolphthalein correctly. Alright, okay, so next one is here, you are given with all these steps. So you are asked to describe how to prepare a pure sample. You see, a pure sample of sodium hydroxide crystal, okay, from the original solutions of acid and alkaline of the same concentration. Okay, you are not required to give details of how to carry out titration. So what can you do over here? So you see, to prepare a pure sample of sodium sulfate. So what you can do is, so the very first step, repeat the experiment, okay, using the same volumes of sulfuric acid and sodium hydroxide, okay, but without the indicator. Yeah, because we already know, okay, what is the volumes of acid and alkaline needed. Okay, then we heat the solution until crystallization point. Then we leave it to cool and evaporate. Okay, last, then crystal be formed, then we filter out the crystals formed. Okay, always remember, every time after filtration is carried out, it is always followed by these two standard steps. Okay, we have to rinse the crystal with distilled water. Okay, it is to remove the soluble impurities. And then we dry with filter paper. So this is how you obtain a pure salt crystal. And that's it, easy 5 marks. Alright, okay, then an ion cation test. So you see, flame test is carried out. So what is the metals ions present? Sodium. So you see, when it's sodium, so the flame test, it will be yellow flame in color. Okay, then copper 2 oxide is added with X. So what are the observations? You see, X contains also hydrogen and sulfate ions. You see, it's like sulfuric acid. So we know that this solution is also acidic. So copper 2 oxide reacts with acid to produce what? Salt and water. So which needs to be solution, isn't it? So what happens to the copper 2 oxide solid? So the very first observation, copper 2 oxide solid, okay, copper 2 oxide solid dissolve. Okay, and next one is we know that copper 2 solution is produced. And we know that copper 2 solution is blue in color. So therefore blue solution is formed. Okay, next one, acidified aqueous barium nitrate is added. You see the word barium. Whenever we see the word barium, we know that it is used to test for the presence of sulfate ions. You see, barium sulfate will be produced. So therefore, observation, white precipitate is formed. That's it. Ta-da! Okay. So next one is define the term catalyst. So catalyst is used to speed up the rate of reaction. See, 2 marks for how. So how is speed up the rate of reaction? By lowering the activation energy. That's it. Okay, then see, given with this experiment, so we know that this is what we call the mass loss method. Okay, so given with this graph, so suggest why the mass of the flask and contents decreases as the time increases. You see, mass loss method is for reaction that produces gas. See, if you refer back to the reaction, you see given here, hydrogen peroxide produces what? Oxygen gas, isn't it? So the oxygen gas is able to escape out from the conical flask. Okay, oxygen gas can pass through the cotton wool. So when the gas escapes, so what happens to the total mass? The total mass would decrease. So this is the reason why the mass decreases. So because oxygen gas escape. Okay, then describe what happens to the rate of reaction as the time increases. You see, as the time increases, what happens to the rate of reaction? So you see, first we look at the gradient. See, gradient, it gets less steeper, so rate of reaction decreases. But see, after a certain time point, it becomes constant, isn't it? So it means that the reaction stops. Okay, so see 2 marks what? So first, you have mentioned rate of reaction decreases and eventually stops. That's it. Okay, then the student repeats the experiment at a higher temperature, or the other conditions stay the same, but the rate of reaction increases. So I explain in terms of collision between particles why the rate of reaction increases at a higher temperature. You see 3 marks. So first, what happens when the temperature increases? Particles that have higher kinetic energy. So therefore, particles move faster. So eventually, rate of collision increases. So therefore, particles that have sufficient energy to react. That's it. Okay, please be reminded to include the key point. Particles have sufficient energy to react. Okay, then draw a line on the graph in B for the experiment at higher temperature. So higher rate, steeper the gradient. Okay, and then it reached the maximum faster. Yeah, it should be something like this. Okay, see, not too hard. Next one, organic chem. So you see, ethanol is a members of homologous series of alcohol. So give 2 characteristics of members of a homologous series. So what are the characteristics again? So they have the same general formula. What else? They also have the same functional group. Okay, next one. See, ethanol, it can be produced from ethene, and ethene, it can be made from long chain hydrocarbons, like example decane. So name the process used to obtain ethene from decane. You see, from alkane to alkene. The process is called cracking. So next is given with this. So show the crackings, okay, to form ethene. So you see, you are given with 1 examples of the products produced. So we know that the next products, it has to be ethene. So ethene C2H4. Okay, then just balance the equation. So what is the formulas, okay, of another products? Okay, you have to make sure that both left-hand side, right-hand side, they have equal numbers of atoms. So it would be C4H10. Write the chemical equation for the conversions of ethene into ethanol. So ethene undergoes hydration, okay, added with steam, H2O, to form alcohol, C2H5OH. Okay, then name the types of reaction that happens when ethene is converted into ethanol. So what types of reaction will be taken place? Hydration. Okay, and what are the conditions needed for hydration? See, you are asked to give only 1 condition. Okay, so what are the conditions again? Temperature 300 degrees Celsius, pressure 60 atm, catalyst phosphoric acid. Okay, any of these, they ask you to give only 1. Okay, then ethanol, it can also be produced by fermentation, okay, of glucose. So give 2 advantages of producing ethanol by fermentation, okay, compared to compared to hydration. Okay, so what are the two advantages of fermentation by comparing with hydration? So fermentation uses renewable resources. What else? Okay, fermentation also needs lower temperature compared to hydration. So therefore, lesser energy will be needed. Then given with this, okay, so next one is given with this. So state the test of chemical reaction between ethene and chlorine in this equation. You see, you have to look very carefully. See, look at this equation itself. See, from C2H4, it reacts with Cl2 to form C2H3Cl and HCl. And you see, from 2 carbon with 4 hydrogen becomes 2 carbon with 3 hydrogen and 1 Cl. See, from here we can see that one H it is replaced by another Cl. Okay, which means that one H and one Cl they exchange position. So these types of reaction we call it substitution reaction. Okay, and then chloroethene monomers, it can be converted into polymer called polychloroethene. So what types of polymerization is this? This is addition polymerization. Okay, and then draw a section of the polymer molecule made from 2 monomers molecule. This is mentioned here. Okay, made from 2 monomers, which means you are asked to draw polymers with 2 repeat units of monomers. So 1 repeat unit and another repeat unit. Okay, so exactly the same HCl, HCl. Make sure that both the end you end with S standard bond. So this is how it looks like. And one more thing, when you draw polymers, isn't it? When there are 2 or more repeat units, you do not need to put bracket anymore. Okay, bracket is only for 1 repeat unit. So in this case, this is how it looks like. 2 repeat units, do not need to put any bracket. Alright, then given with this, you are asked to draw the monomers. You see, we know that this is an example of protein. Okay, you see, 1 monomers, one side with N, another side with CO. Okay, so remember, so one side has to be, remember we pull back the H2O, okay, so NH2, another side we pull back the OH. So this is how it looks like. Okay, one side NH2, another side COOH. That's it. So this is how the monomers looks like. Alright, good. So that's all for this paper. Okay, so if there's any questions, you guys can always ask in the comment section. Okay, hope you guys enjoy this. Thanks. Remember to like the video and subscribe to the channel. See you again. Bye.